Internet! Welcome to Open Source Directions, hosted by OpenTeams, the first business-to-business marketplace for open source services. Open Source Directions is the webinar that brings you all of the news about the future of your favorite open source projects. My name is Melissa. I'm a mathematician and software engineer based in Brazil, working with open source software and communities at Quantsite. And I'll be your host for Open Source Directions. Co-hosting with me today is...
Hi, I'm Madikin. I'm excited to be the co-host for this episode of Open Source Directions. I'm a postdoc at the University of Illinois at Urbana-Champaign. I work on an open source project called the YT Project, and I'm based in Urbana, Illinois.
Hi, I'm Brendan Collins. I'm the co-founder and principal at MakePath and also the leader of an open source project called Xarray-Spatial. And I'm so thankful to be here. Thank you guys for inviting me on, and really happy to be here to evangelize Xarray-Spatial.
Glad to have you. But before we get into the details about Xarray-Spatial, we are going to do our PR of the week section, where we each discuss like a fun little PR that we saw during the week. So Brendan, you want to get first?
Sure. I don't mean to focus too much on Xarray-Spatial too early, but the PR that I wanted to highlight is within Xarray-Spatial. It's a PR submitted by Tweed.m, who's a very active developer in Xarray-Spatial, which adds GPU support for our hillshade function. So the hillshade function will take an Xarray object or a NumPy array and produce one that looks illuminated by a light source. And so Twee has taken that and enabled that for CUDA GPUs. So that's an exciting PR at Xarray-Spatial.
That's really cool. So I just want to mention a quick one, which is I'm actually cheating because it's a PR, but it's a PR for a blog post, which I found pretty awesome about designers in open source. So about the roles that designers play in open source communities and how can they better communicate with developers and how do they find out their own place in open source communities. This was a blog post written by Tim George and Isabella Presedo-Floyd from Quantsite, and I just thought it was awesome. I just wanted to share. Madikin, do you have something?
Well, I'm going to say that there's so many great pull requests out there that I couldn't possibly choose between all of them, I was very indecisive. So I would just like to highlight an open source news of the week, which is the new CCI funding for NumPy. So I know Melissa is going to be working on that. So congratulations, NumPy. Yeah.
Yay.
Yeah, great. Everybody, yes, we need funding for open source. So congratulations, NumPy. I'm very proud of you.
That's great. And to yes and that one, also congratulations to Bokeh on the CCI grants. Bokeh also received a grant, which MakePath will be participating on and helping to add better support for publication-ready exports from Bokeh plots.
Oh, excellent. Yes, I think the publication-ready plots is like super important in data viz, otherwise then you can like actually communicate science. So that's fantastic. Congratulations also, Bokeh, and by extension, MakePath.
Yeah,
thanks for the Bokeh team for that.
Yeah, I think there's congratulations to all the grantees. There were a bunch of really nice projects selected, and also the ones that maybe weren't selected, but who definitely deserved and also deserve funding. So let's try and make that happen for everybody. Would be nice to have more funding for open source projects.
Absolutely.
Okay, so I think it's time we get to Xarray-Spatial. This is a raster-based spatial analysis library in Python. It implements common raster analysis functions using Numba and provides an easy to install, easy to extend code base for raster analysis. It has about 150 stars on GitHub, and we are counting 160 downloads a month across PyPI and Conda. I'm pretty sure this is like used for research, for industry, for a bunch of other applications. So we're very happy to have you, Brendan, to talk about it.
Oh, yes. Thank you.
Yeah, no, we're super excited, Brendan. Can you tell us a little bit about who started it, why it was started, and what need it fills?
Yeah, sure. So Xarray-Spatial is a suite of raster analysis tools. The history of the library has a lot to do with the Datashader project. So Datashader is a general purpose rasterization pipeline written in Python, and that's sponsored by Anaconda, and was founded by Peter Wang and Jim Bednar. I had the privilege of working a lot on Datashader in the early days. And as we went, I love geospatial technology, and I always wanted to add in new geo features into Datashader. And it became apparent that the mission of Datashader was really about a rasterization pipeline, not about spatial analysis functions. So as we grew a suite of these analysis functions, we then moved those into a separate library that I started and maintain. And Jim Bednar was really helpful, and Anaconda was very helpful in getting that project launched, and being able to start doing things like deprecating those analysis functions within Datashader and moving those to Xarray-Spatial. So in the geospatial world, there's fundamentally two different types of data sets that we deal with. Their names collide with other domains, but within GIS, we have vector data and raster data. The vector data is representing discrete phenomena. Things like county boundaries, points, lines, and polygons are like the types that we think about on the vector side. That's our Adobe Illustrator for designers. Then on the regularly gridded data set side, that represent continuous phenomena. Things in the geo, we think about elevation, rainfall, any of like soil types. Those are many times better represented as grids. And that's the raster side of GIS. So what Xarray-Spatial is trying to do is really connect two different communities within data science, which is one, the array computing community, which is familiar with NumPy, and then the GIS community, who are familiar with geospatial tools and sometimes need spellings that are more geared towards GIS professionals. So as an example, a GIS professional thinks of slope, and other, say electrical engineers think of np.gradient. Those are very similar functions, but have different names. And if I want to help the GIS community use these amazing tools from the more general Python data science community.
Can you explain to us a bit about the history of the name and the logo for the project?
Yeah, so the name is really an ode to the Xarray library. So Xarray is the fundamental data structure that we use for the inputs and outputs from functions. The logo, Sarah Miller, who is a great designer, local designer here in South Austin, designed the logo for us, and that was a nice thing to have to add more structure to the project and be able to have a sweet Slack icon and stuff like that. So there's a little history there, and shout out to Sarah and Sarah Miller Designs, who does great work. And but yeah, so the name is based on the Xarray library, and then also spatial is a little on the nose in terms of what it does, because that's the main focus, but naming can be difficult. But right, Xarray-Spatial is hopefully tells the story of what it's meant to do quickly.
Yeah, I think I admire the name, and I also sympathize with the struggle of naming a package something.
Yeah.
But that's also like draws people in, so maybe that's clever. It's challenging for sure.
Mm-hmm.
Can you tell us if there's any alternative projects out there that might fill a similar void, and how you differ from them?
Yeah, so there's some great projects, and a lot of these projects are ones that we actively use all the time. So one of them is Rasterio. So Rasterio is, I believe, was created by Sean Gillies, and it wraps GDAL to be able to provide raster support for the Python ecosystem. It's great, and GDAL is great, and GDAL has 20 plus years of development behind it, and is an awesome library. Rasterio ties into Xarray also, and that's a nice hook. Raster-Stats, which is also from that same Rasterio ecosystem, and PeriGeo on GitHub, provides some nice zonal statistics tools Xarray-Spatial also includes zonal statistics, and the idea behind zonal statistics, right, is that we're taking one grid and we're summarizing another by it. So we may have unique values that represent zones. We could imagine polygons on one grid, and we want to get basic summary stats, min, max, standard deviation, variance for another grid. Raster stats is a library on GitHub that will also do that using GDAL and does it really well. So that's some overlap with our library. Now, the main difference is our interaction with the C level. So GDAL and Rasterio, raster stats, they interface with C by wrapping up C and C++ into C extensions. Xarray-Spatial interfaces with C by using the Numba compiler. The difference there means that we can extend Xarray-Spatial within Python very easily. So you can access all the core algorithms that are running that are actually in, say, Rasterio or raster stats implemented at the C++ level inside of GDAL. You can access that within Python, and then you can extend that. And that's one of the main technical value propositions of Xarray-Spatial is its interaction with the C level. So instead of everything is written, you can extend that without having to change languages.
Yeah, that's so cool. And I feel like you already answered my next question, but I just want to remind the audience that you can ask questions in the chat. So we'll do our best to try and answer them at the end. We'll have like a question session at the end. But so what technology is Xarray-Spatial built on? I feel like you're already mentioning some of that stuff, but is there anything else you want to talk about?
Definitely. So Xarray-Spatial falls inside of the Pi data stack in general. So the core dependencies of Xarray-Spatial include Xarray, but also Datashader for some of the rasterization, Numba, Dask, Pandas, NumPy, and also Spatial Pandas, which is a library that came out of Datashader also for vector geometry, headed up by John Meese. That is another library on the Xarray-Spatial README. We have a graph that shows the dependency libraries and also optional dependencies. So just a shout out to a couple optional dependencies, definitely Rasterio. So if you do want to use GDAL, there's integration there, especially for input-output, say reading geotiffs. And then also things like HoloViews, which allows you to easily compose beautiful dashboards and visualizations in Python. So we're trying to play well with the whole data science ecosystem within Python, including Jupyter notebooks, and so that a little note on that. Yeah. Madigan, I think you might be on mute.
Oops, sorry. Yep, I was on mute. So when I want to type, I just don't want you to hear my mechanical keyboard. So, yeah, so thank you. So you mentioned a little bit before when you were moving functions from Datashader into Xarray-Spatial that you said now you're a person who's maintaining Xarray-Spatial. Who else maintains the project? And is there anybody else?
Yeah, so we currently have about 10 contributors. 8 actual listed contributors, and we're definitely have been moving outside of the MakePath circle contributors, specifically for the focal statistics module. We've had some really nice contributions there in running kind of kernels over rasters and doing things like hotspot analysis, where you can pull out statistically significant areas of a grid. And that has come from outside of the MakePath group, and that's what we want to see. MakePath is sponsoring this project, but we don't want to see all the contributors be from MakePath. We want to have this be a well-supported project, and potentially also move this into a proper organization, as opposed to being inside of the MakePath company GitHub organization. So there's some things that I think we could work on there in terms of making sure that there's more community involvement, and some of the efforts around also participating. So yesterday, over the past couple of days, we've been celebrating International GIS Day. And in Austin, there's a conference there, and we're trying to get the word out about to GIS professionals about Xarray-Spatial and adding Xarray-Spatial to your existing toolkit so that you can deal with any situation that comes up. We're really trying to frame this as a really nice complement to existing GIS tools. So if you're someone that uses ArcGIS, or you're someone that uses QGIS, you should look at Xarray-Spatial as a supplemental raster library that you could use to solve a problem where you might not be able to hold all of the data on one machine and you need to scale out to a cluster. That could be a good use case for using Xarray-Spatial with Dask and being able to solve a problem that you couldn't do on a single workstation.
Yeah, so you mentioned GIS professionals, but that's like a big group. So what communities are your users and potential contributors from?
Well, there's a big focus on Python. And so that's one of the major first dividers in the site, is that we're focused on the Python community and making sure that the experience for people wanting to invest in that, whether they're beginners or they're experts, that they have good support in terms of modern package managing, all of the tools that we need to support contributions that come in. So there's that side, and there's a major focus on people that would classify themselves as GIS analysts. These folks a lot of times are coming from a deep domain expertise, but may not have the software engineering background to appreciate things like C versus Fortran, row major, column major concerns. If we could take tools like CUDA and empower GIS analysts with very specific domain expertise, say in conservation, to use GPU hardware to solve their problems, then that would be a big win for us. And so that is a little bit inside of where my head is at in trying to support domain experts that don't want to learn threads, blocks, and grids in CUDA.
Yeah, and just to kind of like build a little bit off of that, I think it's challenging, like when you start kind of building in this like domain specificity into your libraries, that then it automatically makes it sort of exclusionary to other domains. And so like trying to make your library both accessible to very specific domains, but broad enough that like other people can come in is very, very challenging. And I don't have a good solution for this, but I can imagine this is a problem you're thinking about a lot.
Yeah, and also not always just thinking by analogy to some other tool where you're just always thinking, okay, well, this tool had that tool, so we need to have that tool.
Yeah, yeah.
But focusing a lot on the scaling issue of helping people to scale this type of analysis to even just multi-core. Being able to provide what the Dask bag provides, but just with a spelling that's familiar to people, within GIS, is one of those stories we're trying to support.
Yeah, cool, very cool. So can you tell us a little bit also if there are any diversity and inclusion efforts that Xarray-Spatial is working on or implementing or interested in doing?
Yeah, so I would say kind of like the first thing there is that it is open source, right? So that just at the beginning of being able to have a code base that anyone on GitHub can come to and read and contribute to starts that process of building a inclusive and diverse community. I think that we all want to maximize the value an open source project to the world, and that means that if there's people that are coming to the table and aren't able to contribute for some immutable characteristic about who they are or what they do or where they're from, then that hurts that value proposition of delivering world-class tools that are open and free. I think that that dealing with issues where people are excluded or there's community problems within Xarray-Spatial starts with a code of conduct, and having a reference point that you can look at to make an issue not subjective. So one of the goals there is to make, if there is a problem, it's not a subjective thing. It's something that we can point to a document that's not one person, but that is an agreement between all of the participants, and say something that happened in the project was wrong, and it was wrong because it violated a code of conduct that we all agree to. So that's one of the at least defensive tactics that we're using, which is very common among projects, to be able to have some of that foundation. God forbid there is a problem where someone is excluded for some ridiculous reason, and that's a little speaking to that. But that's what we want. I mean, we want people that we're addressing very difficult problems. There's a lot of different cases, and it requires a very diverse group of minds to solve those cases. So hopefully we can do more. Are there any suggestions that you've seen in other projects that when you think about Xarray-Spatial, you say, you know what, we had another guest or another look at another project as being particularly exemplary in the area of inclusion?
I don't have like a specific project. Something I've been thinking about is like trying to create some sort of onboarding or mentorship program for like new contributors. So like, if you see somebody is new, trying to come up with some sort of like, way to make sure that they like are immediately included by the community and like have a pathway to like become a part of the community, if that makes sense. Yeah, so that's something I've been thinking about, and I know it involves like a lot of ask from devs. And, on my project, we don't have a lot of developer time. So, of course, there's tension there. But it's something I've been pushing for. Yeah. So, Melissa, do you have any thoughts?
I see that Tony is mentioning Kedro in the comment. And Kedro was part of Open Source Directions a few episodes ago. And they definitely do have like a whole focus on documentation and on like bringing people in through information, but also through that contact as like mentoring and onboarding and having people who are open to having that discussion and just making people feel comfortable contributing at whatever level they are, like meeting people where they are if they want to contribute and bring them in the project. So I think those kinds of active initiatives, like code of conduct is like a static thing, like it's in your community and it makes it better for existing, but you don't have to necessarily do something, it's just there. But having those active initiatives is also extremely helpful, especially if you feel like your project is missing people, is missing some group, or which is what happens, unfortunately, in many projects.
Yeah, that's true. Thank you so much for mentioning Kedro, Tony, and Melissa, like highlighting some of their work. I really think they deserve like humongous props. They had so many different initiatives. It's not just one thing. It's just like from very small to very big. It was really impressive, some of their work.
I think it's really interesting also, like in this new era of remote work where we have a new focus on remote work, how that new culture influences inclusion and diversity in open source. And so like a couple of things jump out as I've been thinking about this. One is that it's nice that everyone's remote and we can be on an equal playing field in terms of seeing commits and PRs come in. But also sometimes the remote nature of not seeing people face to face means that people behave in ways that aren't as nice because they don't really feel the impact of the statements that they make. And so those are just some of the things, questions in my head that I've been playing around with in the new remote era.
Yeah, I think also something I want to mention is that I think, because we're all remote and kind of isolated, right? I think that means inclusion is extra important, because if somebody's already feeling sort of, on the outside and then they get some really rude comment or, degrading comment in a PR, it hurts more, right? Or it hits harder. And so like being a truly inclusive community, I think, is extra impactful in a time like this.
And also like there's a tendency for people, like it depends, your life situation might influence how you see things. So for example, for me, I know that being remote is extremely hard and much harder than it was before because I have a kid and he doesn't have school anymore.
Yes.
So I have no free time. I have zero free time, which if I didn't contribute to an open source project in my day job, I would not contribute at all. So
Yes.
we are missing a lot of people who are having like family obligations, have to take care of loved ones, of children, of elderly. So it is hard on many people. So yeah, this is just something, just a little touch of
Yes.
reality.
Yeah, I think it's an important point, Melissa. I mean, the fact that there are people who are not being included right now based on the work situations that are existing is really a problem, right? So yeah.
So anyway, I think we can move to the project demo. I don't know.
This
if
is a
you
great
guys-
tangent, though.
It
I
was,
loved it.
yeah, I loved it too. So yeah, I think we can go to the project demo and see
Great.
some of the cool features of
Let me go ahead and share my
Xarray-Spatial.
screen here.
Yeah. So while you're getting set up, we would just like to take this opportunity to thank our sponsor, QuantSight, for sponsoring this episode of Open Source Directions. QuantSight, creating value from data. So whenever you're ready, Brandon.
Great. So are you guys able to see my screen now? You should be seeing the Xarray-Spatial GitHub.
Yep, I can see it.
So first, we're looking at the GitHub page for Xarray-Spatial, and we can see some of the installation. I'm going to make this just a little bigger so folks can see. And some of the descriptions. Here we have a list of the supported spatial functions and their supported inputs. So when we look at Xarray-Spatial, we're doing raster processing basically on X arrays, which wrap NumPy arrays, but they can also wrap Dask arrays and CuPy arrays. And then we also want to support a Dask GPU input. And so this first lists the spatial functions that we support, things like classification, surface analysis with curvature and slope, multispectral analysis with things like NDVI and a lot of the different flavors of NDVI. You could use these tools on top of Landsat data. And depending on which flavor of Landsat you're dealing with, you may use different bands. The bands might be a little different, but you can still use these tools on them, so NDVI. We have a bunch of proximity tools. So these are about calculating distance or associating features with their closest neighbors. Direction would allow you to do things like say, what is the direction to the nearest location? So I want to know in 360 degrees. So let's take a look at a couple of these tools in action. To do that, I'm going to come up to the examples area and go over to the user guide. I'm just going to click on this first one, which is the surface tools. It's a little description of what we're trying to accomplish with these surface tools. Things like hill shade, slope, curvature, and aspect. Aspect, for folks that may not know, is the direction that the slope is facing. Well, curvature is the second derivative of the elevation, and slope is the first.
Now you're bridging the gap between non-GIS people and GIS people, because there's no way I would have known either of those things.
Exactly. And so and you can imagine viewshed is basically like one-step raycasting, where we're connecting points that are in line of sight of each other, but not continuing the cast after one hit. So when you're using these tools, you need a grid to work with, and so we provide just some procedurally generated terrain to play with. And this is just some Perlin noise that we're playing with. And we're using Datashader here to apply a color ramp, the elevation color ramp with a linear stretch. And we can start to see how we can use Datashader with Xarray-Spatial to interactively do analysis and see the output of that analysis as we go. So we're taking the same elevation data set, and now we're illuminating it using a light source at a specific altitude. And we can composite these two images together using Datashader, using Datashader's stack. So here I'm taking an illuminated terrain and stacking it with a color mapped elevation terrain. Slope, where say we have the use case where we're worried about avalanche, and we've defined a threshold for avalanche based on slope. We could take the slope of the terrain, use NumPy to threshold the slope, and identify those areas in red that we believe might have additional avalanche risk. Curvature, you can think about second derivative acceleration and some other use cases. I'm not going to go too deep into curvature, but know that this is here. And aspect, another surface tool. On viewshed, let's look at a viewshed. In viewshed, we take an observer location, and we want to highlight all the pixels in the NumPy array that have direct line of sight to this observer. And so we've put a kind of a normally distributed little chunk of data in the center, and we run viewshed, and we can see all the pixels highlighted in red that have direct line of sight to our observer. And this works, you can imagine this being used with like cell phone towers, where you're trying to look at the service area for a cell phone coverage. So you can use multiple observers here and specify exactly what the altitude of those observers are and what the altitude above what you're trying to line up with is. So if you're trying to make sure that you can see 10 meters above a target, those are some of the parameters that you can specify within Hillshade.
I have a question about this image, actually. So you have the, there's like a dark gray behind this conical feature, and then there's white, and I'm assuming white means that you don't have a direct line of sight. So what is the dark gray, just like extra bad line of sight because you have something in front of you, or?
It's actually just illuminated with Hillshade to give you the impression that there's height here.
Okay.
So you can kind of imagine that this observer, and it might be a little hard to see, it's orange right here, is not able to see anything behind this little mountain.
Yeah, okay, I see. So you have like both the line of sight data and this Hillshade overlay.
Exactly.
So you can still see the features in addition to the data of the line of sight.
Yeah, and the output grid is actually not only the line of sight, but the angle to that spot.
Okay.
So we see that the actual red here is lighter as opposed to darker here as we get to the top. It might be kind of hard to see, but so that output grid includes the direction that the person would look to hit that point.
Oh, interesting. Okay, cool.
And that's helpful for thresholding, right? Because you want to maybe filter by that afterwards. So this is just an example of kind of on this terrain. If we were an observer on this slope, what could we potentially see here? And we have some references, and we didn't really invent any of these algorithms. We're trying to take these algorithms and make them fast using Numba.
Very cool. I have another minor question about this with your grid data. Does the data always have to be a regular grid, or do you also support non-regular grids?
Right now, it's regular grids right now.
Okay.
And we need to have a good abstraction for how we deal with, polar coordinates, and we don't dive in too much into like the curvilinear rasters, but the rasterization process of getting points, lines, polygons, tri-meshes, quad meshes, and other rasters into a shape that's usable for Xarray-Spatial can be done using Datashader.
Okay.
So Datashader can handle, for instance, if we think of the Sentinel-5 European satellite data, that comes in curvilinear coordinate system, and that you can aggregate to a Datashader canvas within Datashader, and now you're dealing with a something that can be aligned with a rectilinear grid.
Okay, this is extremely cool. I'm just like having so many great questions coming through. So yeah, I love this demo. It's great.
Anything else you want to show, Brendan?
Sure. Just one other is that zonal statistics tends to be one of the very high value tools within the GIS ecosystem. This is where we're, and let's just look at a quick example of that and how you would do that in Xarray-Spatial. It's just a high value tool. We have our same terrain. And this time we want to imagine that we're hiking across the terrain over 5 or 6 different days. And we want to look at the summary stats of the terrain for each one of our day segments. We can use zonal stats to do that. So here I've rasterized my trail segments using Datashader's line feature or line function on top of a canvas. And then I'm going to use Xarray-Spatial zonal stats to then use the trajectory data to calculate the summary stats of the underlying elevation data. So here we have 1 record per day of our hike, and we have the mean elevation, max min, and all the the summary stats that we want for that part of the hike. The Xarray-Spatial also allows you to define any custom zonal stats functions that you want. So as you want to extend this for your own purposes, we will call this function, and with the input zone rasters that you need to, or NumPy arrays that you need to do your calculation. So you can do custom zonal stats for each zone.
Looks really cool, and I bet that has applications well outside GIS community. Like I can see using that for planning a hike, or for like I don't know, planning like a running training plan. Like yeah. I mean, you can see that being used by a lot of people, and you can see like it's a nice API, and I just think it's really cool.
Oh, thank you.
Yeah, it's very cool. I would plan my run with minimal elevation change.
Exactly.
Being a Midwesterner, I'm used to flat, so let's not be on the mountains. That'd be great,
Yeah.
or just stay at the same elevation the whole time.
I could certainly go on about zonal stats for a whole other podcast probably, but so if anyone has questions about this, please feel free to reach out to me, and I can help answer any specific questions on zonal stats.
That looks really, really nice. And I really like the examples. And I just want to know if you have you can definitely, if you have any other stuff to show, you can definitely go on. But I just want to know, do you have an idea of the roadmap that lies ahead for Xarray-Spatial? Mm-hmm. What are your plans for the future? Where is the project going? And where are the priorities of the community right now?
Yeah, so right now we have a couple of different kind of roadmap features. One is better documentation, making sure that the documentation is robust and that we fortify the library for all the tools that we already have, as opposed to adding a lot of new tools. That's one of the themes in the short-term roadmap. We want to build out a better Xarray-Spatial documentation site. We have one now, but it's an old build of the Sphinx, and we need to update that. So documentation is very important here. And then our main story now is going to be scaling the tools that we have. So I'm going to zoom out a little bit just so you can see this full table. But we're filling out this table. So for instance, the aspect tool of what direction a slope is. We want to make sure that works with CuPy GPU arrays right now, but we want to make sure it works on a GPU cluster and that it works across just a standard cluster. And if we look at if you don't mind, I could actually show some code real quick of what that looks like.
Yeah.
And how easy that could be for someone to help contribute.
That would be awesome.
Here's the slope function. And if we go to the bottom of the slope function, we're going to see the public slope method here. So all of the functions take in Xarray data arrays, and you can assign the output a name that's part of Xarray. But what we do in each one of these functions is that we just have to try to handle these 4 cases. So if the Xarray object is backed by a NumPy array, we run a NumPy case with CuPy, a Dask array with a CuPy backed Dask array, or a Dask array with a NumPy backed Dask array. And so as we go through this, slope is a good example of how, if you wanted to contribute one of these functions for another tool which lacks it, that you could look at slope as an analogy and copy some of this code. So most of the code, for instance, if we look at what it's like to run slope across a Dask CuPy array, we can just look at this function here and maybe take that and use it for the hill shade, which doesn't currently support hill shading across a GPU cluster. So this is going deep into the weeds here, but this is what Xarray-Spatial looks like on the inside, is that we have just a bunch of Numba JITted functions that apply to either the GPU, so this is the GPU of slope, or the CPU version, which is a Numba function for running horn slope on a CPU. Yeah. So quick, into the weeds here with Xarray-Spatial, but slope in particular is a good module that if you wanted to make a contribution, you could use slope as an analogy to extend things.
Yeah, I think this is great. I mean, knowing that you need this, right? And if somebody wants to contribute, that they know a good, robust module that exists to model stuff off of, I think is really helpful, right? And that's like a nice pathway for a new contributor for your project, And you mentioned you wanted people outside of MakePath, so it seems like this is a nice option, Is there any related to this a little bit? I'm going to ask you a little bit about contributors now. Do you mentioned kind of doing community work outside of your to the GIS community. Have you been successful in getting GIS contributors to the project? And how have you been doing this sort of outreach for your project?
So I think a lot of we have been successful in getting some good contributors from outside of MakePath. Not too many. I mean, the project is fairly small right now, but the majority of the contributors are outside of MakePath. And now this is a very small sample because we only have 8 official contributors, but making sure that on the outreach that we're letting people know the problems that Xarray-Spatial solves in those domains. So I'm really thinking here, there's people that don't classify themselves necessarily as GIS professionals, but in fact do a lot of spatial analysis, especially in academia. We'd be very interested in getting more contributions from just different domains in academia that use things like our hotspot tool to look at statistically significant hotspots on an area. The ATX GIS day that we were participating in letting people know that this exists. Most people actually just don't know that this exists at all.
Right.
And getting that word out is really helpful. And so, thank you guys so much for having me on here on this, because this is really helpful for Xarray-Spatial to get more contributors.
Yeah, are there any like additional features that are in the GIS community that you haven't built out yet? Like you mentioned that this is a library of, sort of GIS functions or like functions, spatial functions, right? So like what, additional features are you kind of looking for?
And also, like, just related to this, just to complement the question, are there I know that, for example, in academia, it's very common that you use commercial products, or maybe in industry, you have like a different closed source products that do the same thing. Do you have like a plan for bringing those people in, or, like doing outreach and telling everybody that there's a free open source version of the same thing they're using?
Yeah, that's a great question. And something that I'm trying to frame Xarray-Spatial with is that even if you're a dedicated user of a proprietary product, there's a role for open source and Python and Xarray-Spatial within your toolkit. And trying to break down a little bit of the us versus them open proprietary dichotomy, and seeing how simple functions that can be added to link those tools together to ultimately get analysts to have a better overall set of tools. So one of the things that we do here is that the most popular GIS proprietary software package is Esri's ArcGIS desktop. ArcGIS has Python integrated into it, and they have some really nice functions, for instance, raster to NumPy. So within the ArcGIS community, they have access to be able to convert their proprietary data formats into NumPy arrays. This is on very short-term roadmap. We are adding in utility functions that if you have the ArcPy library installed on your system, then we can read ArcGIS proprietary rasters just using this raster to NumPy and NumPy to raster. That is very low-hanging fruit for Xarray-Spatial and adds a ton of value for anyone that's in that ecosystem and needs these tools to integrate.
Yeah, I think the interface between proprietary tools and open source is very interesting, right? Like, I think there are a lot of specific domains where you're required to use, like to do any work in it, you have some requirement of using proprietary software. And so, trying to complement that with open source so that you can still do your analysis publicly, even if the way that the data is generated is maybe proprietary, still has a lot of benefit, right? In my case, in nuclear engineering, we don't necessarily have proprietary in terms of business proprietary, but we have a lot of export controlled tools. So there's nothing I can do about that, right? Like I can't not use export controlled stuff in some cases. So I have to do that. So doing my analysis publicly instead is like a way to kind of be open source and live through an open source ethos. So it's nice that you're building that for the GIS community.
Yeah. As long as this is so easy, it's so easy to integrate this that it doesn't really, at least for me, have to become like a philosophical issue of integrating with a proprietary piece. It's just easy, low-hanging fruit that we can do to empower those people that are already using ArcGIS and want to use it.
Well, thank you so much, Brendan. I don't know if you have final notes, things you want to say before we move to the questions, because we do have a couple questions to answer.
Yeah, I mean, just so happy to be here, and thank you guys so much with OpenTeams and all the questions coming in.
Yeah, so we'll go to user questions. We have a couple ones. So first, as you are building new communities around an open source project, what are some other open source projects that provide you with good models, examples, to understand how to grow and support your emerging communities?
I learned a lot from some of the communities within Python, Dask in particular, Dask and Bokeh. Both of these projects helped me learn what it is to contribute to open source and how to participate in an open source project. And I would really like to encourage anyone that's interested in contributing to Xarray-Spatial that there are needed contributions on every skill level. So if you're new to programming altogether and are interested in the domain that Xarray-Spatial is addressing, then there's a role for you in the project in terms of helping out to define features, to test features, to help with documentation and other things if you don't want to directly contribute to, say, GPU code. So there's just letting people know that there's need at every level. Everyone can be a valued contributor to Xarray-Spatial. So please, come by and check it out.
Melissa, why don't you ask the next one and I'll ask my last one.
Yeah. So just a second one is, does MakePath have any specific ways that they support a remote working culture?
Definitely. So MakePath is fully remote. We started fully remote from the beginning. And in doing that, there's some unique challenges. Most of it's actually very smooth, but we do things making sure that we prioritize using video, making sure that we're having a lot of conversations and prioritize communication over, extensive, documentation on certain things. So there's unique challenges to remote work, but I think it's also making sure that people stop at some point. In everyone working remotely, I am fall into this also, where sometimes there aren't clear stopping points for folks, where there isn't a nice kind of work-life balance for people that are always in their office because their office is their home. So we like to also make sure that people are taking care of themselves in terms of not working too much. But I really like the freedom that remote work gives you, and I'm not a big fan of a commute. So really like that.
Yeah. Okay. So the last question is a question for me, and it's related to when you were talking a little bit about how Xarray-Spatial came into existence, because you had all these very specific spatial functions in Datashader. And so I'm curious, so I think a lot of projects struggle with modularity and not becoming too bulky as a project. And so I'm curious, like, how did you plan this process where you spun out some of those functions and deprecated them from Datashader and created this new library? And was there growing pains with that? And can you talk a little bit about that? Because I think that's very interesting.
Oh, yeah. So there were some growing pains. There was certainly just being able to deprecate that code from Datashader, and making sure that those users were supported and anyone that was using those functions, including downstream libraries from Datashader. HoloViews is one that does wrap Datashader for certain things, and there was some risk there of breaking other people's APIs. I actually was trying originally with Xarray-Spatial to implement polygon rasterization, and then it just kind of spun out. And I think that being able to figure out what to say no to in terms of features is important. So we're only focusing on Numba-ized raster functions. If it doesn't involve, if it involves, for instance, GeoPandas and manipulation of vectors, not going here. That's another library, and that's having a clear mission statement of what you're trying to do is important, so that you can evaluate new features against that mission statement and decide whether they're valid or not.
Answer your question, Madikin? Do you want to comment on that?
No, I thought that was great. I mean, I think this is like, a great sort of conversation that can, continue in other places outside of this webinar. But I thought it was very interesting, and thank you, because I think it's a challenging problem, I think, when you start doing these sort of when you start spinning out functions from one library into another, and it's a very interesting story. So thank you for sharing that. Oh,
thank you guys.
Yeah, and I definitely agree. I think like having a roadmap seems like such a healthy thing for any project to have. And it is hard when you see projects that don't know exactly where they're going. And that's what happens, is that you end up absorbing too much or not being clear on what you want to do. And then you end up doing a lot of things that are not your main priorities, but just because you can't say no. So yeah, I absolutely agree with that. And I think that's a very healthy way to organize your project. Okay, so now it's time for our world famous rant and rave section, because we're nearing the end of the webinar. So each of us is going to get 15 seconds to rant or rave about whatever topic we want. So Brendan, do you want to start?
I guess I would like to rave about Numba. I've been learning about CUDA programming. I'm still a novice, but I'm getting up to speed, and I'm absolutely blown away by what the power of Numba and how easy it is to write what is very complex code on the C side. So I would like to rave about Numba and how impressed I am by Numba.
Okay, well, I'm going to rant. You're so positive, so I have to compliment you with something frustrating, which is I am really annoyed that Christmas music starts so early. Like, why? I know we started this webinar talking about Mariah Carey, but she's like an angel, so doesn't count. But why does it start like this year? It started right after Halloween. I don't need 2 months of Christmas music. I'm not that person. Stop inundating me with Christmas music, stores and other places. Annoying.
I don't know about you, but I'm kind of do the opposite because I'm gonna rave about Christmas. We're almost there because I think I have like an idea. I have a theory actually that I think people just want to rush the end of the year and see 2020 done and gone.
Yes.
So we can't wait for Christmas and for New Year's and to forget this whole year that has been like so crazy. So that's my theory. That's why it's starting so early this year, because you can't stand being in 2020 anymore.
I mean, I think we could have a much longer soapbox rant about how much 2020 sucks. So, you know, like,
yes.
Yeah.
Yes. And I was able to humanely catch a chipmunk this summer out of my sister's house, and I brought it down to release it into the woods, and I played it the chipmunk Christmas song the entire way. See if I could get, you know, a single singing chipmunk. That was my one opportunity. Didn't want to sing, but you know, that was my first Christmas song of July. Christmas.
I don't know why you did not introduce yourself with this amazing fact that you humanely got a chipmunk. I love chipmunks. Oh my God, I have some like woodchucks that are living in my front yard and I record them. They like chunkily run. If I could have chipmunks and woodchucks, I would be like a woodland paradise, you know.
Oh, so cute.
Well, I think that's an awesome way to end our conversation. And this is all the time we have for today. So thanks everybody for watching. Thanks, Brandon, for being here. We loved it. I think it was a great way to showcase Xarray-Spatial. Thanks everybody for listening. You can find us on Twitter at OpenTeams Inc. and at Quantsite AI. Brandon, where can people find you and Xarray-Spatial?
Yeah, so you can find Xarray-Spatial at github.com/makepath/Xarray-Spatial. And also check out the makepath.com/blog, so you can see some of the use cases that we've shown on using Xarray-Spatial.
Great. So if you liked what you saw today, please go to our YouTube channel and like and subscribe to see more of this content. And I'm not going to announce the next webinar because we're going on a holiday break. So this is the last episode of 2020. And we thank you all so much for being here. Thanks again for the folks in the chat also. And
yeah,
that's it. That's what we have for today.
Thank you.
Thanks
Thank
everybody.
You guys so much.